All right, good day to you, everyone. Today we want to take a look at another aspect of coordinate geometry. The last time we talked about coordinate geometry, we're looking at gradients and the midpoint of the line segment. But now we're going to be talking about the distance between 2 points in a coordinate geometry. So we can have 2 points and be asked to find the length or the distance between those 2 points. We can do that simply by using Pythagoras theorem. So assume we have 2 points on the Cartesian plane like you can see here. We remember that a point is described on the Cartesian plane by the x and y coordinates given or known. So if we have these 2 points, for example, we have the point A, which is 5,3. We have the point B, which is 18,17. Of course, 5,3 means that 5 is the value on the x value on the x-axis, and the 3 is the value on the y-axis. And the second point for B, we have the x value as 18 and the y value as 17. So we can talk about the length of this particular line because we're trying to draw a triangle out of this. From here, beginning, that is the origin, to here, we have that length as 5. Meanwhile, from the origin there to where you have 18, that is 18 in length. So if you have to talk about the length which is between 5 and 18, that would be the full length, which is 18, minus the 5, which gives us 13. In the same way, we can also decide to find the length between this point up here and then this point where we can trace our point A2 on the y-axis, so that the length of this point of this line in blue will be 17 up there minus 3 down there. From here to this point is 3. So we take 3 away from the full length of this, which is 17. That gives us 14. So this length is 14 and this length is 13. So we can use Pythagoras rule therefore to find the length of the line. The length of the line will invariably mean the distance between the points A and the point B. So using Pythagoras rule, we have AB squared equals 13 squared plus 14 squared. And solving that, of course, it came from 18 minus 5 and 17 minus 3. So we've already done that before. So that gives us the square root of 13 squared plus 14 squared. And the resulting will give us the distance between the 2 points. Now, in general, we can make a generalization of what we have just done, and then have a formula that we can call the formula of finding distance between any two points specified on the Cartesian plane. So assuming we have a point A, x1, y1, and we have another point B, x2, y2, we can talk about finding the 2 points, finding the distance between the 2 points A and B. We have the length on this side of the triangle we are trying to form as x2 minus x1, while the length of the vertical part of the side of the rectangle triangle we are trying to form to be y2 minus y1. So therefore, by Pythagoras rule, the length of AB will be found in this manner. By Pythagoras, we have AB squared equals y squared, y2 minus y1 squared plus x2 minus x1 squared. We will take the square root of both sides. That will give us the length of AB. that becomes y2 minus the square root of y2 minus y1 squared plus x2 minus x1 squared. So this gives us the formula for finding the length or the distance between 2 points. Remember, the distance between 2 points formula can also be regarded as the length of the line that is joining those 2 points together. Find the distance between the points 1 minus 1 comma 3 and 2 comma minus 6. All we need to do is simply recall our formula. But first of all, the points that you are given, you can decide to indicate which of them will be your x1, y1, and which will be your x2, y2. So that's very easy. I'm going to make minus 1 comma 3 my x1, y1, and 2 comma minus 6 as my x2, y2. So in this case, I recall my formula. And the next step is just impute into the formula. We have minus 6 minus 3 all squared plus 2 minus minus 1 all squared under the square root. The resulting is 9.49 units to 3 significant figures. Let's take another example. It says find distance between the points 3,8 and 5,4. Find distance between the point minus 2,0 and 8, minus 5. The first one, remember our distance formula is x2 minus x1. You will notice that I have interchanged now. You can decide to write your y2 minus y1 first or x2 minus x1 first. But whichever way it is written, take note that if you have x2 minus x1 here, then you must have y2 minus y1. You should have y2 minus y1 there. But it doesn't still matter because the square root, or the square rather, will take care of the problem of the negative sign that may evolve from the subtraction. But just for the sake of order, when you write x2 minus x1, just write y2 minus y1. And if you can also decide to write y2 minus y1 first before you write x2 minus x1. Either way, you're going to get the same answer. Just take a careful study on the formula. So the next step is to indicate which of them, the points that I'm given, 3,8, 5,4, which of them becomes my x1, y1, and which becomes my x2, y2. So from here, you can see my x1, y1 are chosen to be 3,8, x2, y2 are chosen to be 5,4. Just impute in the formula, we have 5 minus 3 squared plus 4 minus 8 squared. And in that simplification, we have square root of 20. That would be in short form if we were to stop there. But if we press our calculator and simplify 3 significant figures of 2 decimal places, we're going to have 4.47 units as our answer. Of course, in the same manner, we get the second example solved under that question. All right, that does it for this particular problem. See you next time.